There's a device sitting in a museum in Athens right now that should not exist. Not because it is strange, not because it is old, but because everything we thought we knew about who built it, why they built it, and what knowledge they were secretly encoding inside it has just been shattered layer by layer by the most advanced imaging technology ever applied to an ancient artifact. Scientists borrowed tools from gravitational wave detection. Engineers from Argentina ran computer simulations that produced results nobody wanted to publish. Researchers in Glasgow used statistical methods originally designed to decode signals from colliding black holes and pointed them at a corroded bronze object the size of a shoebox. What they found did not just challenge history. It rewrote the conversation about which civilization actually understood the cosmos first, who was borrowing from whom, and whether the most celebrated ancient computer ever discovered was, in a brutal twist of irony, a machine that could barely function. This is not a story about ancient Greece. This is a story about a cover that just got blown wide open. For over a century, the world accepted a clean, comfortable story. Somewhere around 100 BCE, brilliant Greek craftsmen on the island of Rhodes built a mechanical marvel, a hand-cranked bronze computer that could predict eclipses, model planetary cycles, and track the Olympic Games. Why? It was discovered in 1901 in a Roman-era shipwreck by sponge divers who were sheltering from a storm near the island of Antikythera. They found statues, amphorae, jewelry, and somewhere buried beneath the wreckage, an unremarkable corroded lump of bronze that nobody recognized for what it was until a Greek archaeologist named Valerios Stais noticed in 1902 that the rock had a gear inside it. That single observation launched one of the most complex, most expensive, and most intellectually turbulent investigations in the history of science. And more than 120 years later, the investigation is still producing shockwaves. Think about what that means. We have been studying this object for over a century, and we are still finding things inside it that nobody expected. The Antikythera Mechanism, as it came to be called, is now recognized as the world's oldest known analog computer. It contains at least 37 interlocking bronze gears, each one cut by hand with triangular teeth no larger than 1 or 2 millimeters across. The largest surviving gear has exactly 223 teeth. That number is not an accident. That number corresponds to the Saros cycle, the 223 lunar month interval after which solar and lunar eclipses repeat in nearly identical patterns. This was knowledge that predated the mechanism by centuries. It was Babylonian knowledge, and the fact that it was physically encoded into bronze, into gear ratios, into a machine small enough to carry in a wooden box, that is where the story stops being comfortable and starts becoming something else entirely. The device survives today in 82 corroded and calcified fragments, stored under precisely controlled atmospheric conditions at the National Archaeological Museum in Athens, where it cannot be touched. It represents roughly 1/3 of the original machine. The rest was lost to the sea, to time, to 2 millennia of salt water and pressure. What remains is enough to reconstruct its astonishing capabilities, and enough to raise questions that the mainstream narrative about ancient civilization has never been willing to fully confront. Here is where the modern chapter begins. In 2005, a team of Anglo-Greek researchers conducted a major imaging operation on all 82 fragments. They brought a specialized X-ray computed tomography system called the Blade Runner, a machine built by a Hertfordshire firm called X-Tech Systems, from England to Athens. They also deployed Hewlett-Packard's reflectance transform imaging technology to enhance surface details invisible to the naked eye. The results of that 2005 operation unlocked an entirely new understanding of the mechanism's internal structure. Hidden beneath layers of corrosion, thousands of inscriptions emerged. Gear arrangements that scholars had only theorized about were confirmed. The device was not merely a planetary calendar. It was a full cosmological model carrying cycles from Babylonian astronomy, mathematics linked to Plato's Academy, and ancient Greek astronomical theories, all fused into a single mechanical system. Researchers described what they found as solving a complex three-dimensional puzzle, one that revealed a creation of genius. But here's where it gets more interesting. Because every revelation about what this machine could do also made the question of who built it more urgent and more unsettling. The prevailing theory, repeated in textbooks and documentaries for decades, points to Rhodes. Specifically, it points to the intellectual circle of Hipparchus, the Greek astronomer who lived approximately 190 to 120 BCE, widely considered the father of trigonometry, the first person to catalog star positions systematically, and the man who developed mathematical models for the irregular motion of the moon. Hipparchus worked on Rhodes. He blended Babylonian astronomical data, which he had access to through ancient records, with Greek geometric methods. He invented plane trigonometry specifically to solve problems relating to spheres, and the pin and slot mechanism inside the Antikythera device, which mimics the moon's elliptical orbit by making a gear move faster when close to Earth and slower when farther away. That mechanism reflects exactly the kind of mathematical thinking Hipparchus was known for. The Roman writer Cicero, writing in the 1st century BCE, also mentioned devices similar in function that were reportedly made by Archimedes in the 3rd century BCE, suggesting this kind of mechanical astronomical modeling had a tradition, a lineage, a school. What most people are not seeing, however, is how deep the non-Greek fingerprints on this device actually run. The front dial of the Antikythera Mechanism is labeled with Egyptian month names written in ancient Greek. The outer calendar ring was a 365-day Egyptian civil calendar, adjustable for the quarter-day slippage that we now correct with leap years. The eclipse prediction system encoded in its spiral tracks uses the Babylonian Saros cycle. The star positions it references use Babylonian constellation names. In other words, this supposedly Greek device was built around a framework that was fundamentally Egyptian and Babylonian in its astronomical architecture. The Greek genius was the engineering, the translation of those inherited mathematical cycles into physical bronze gears. But the underlying knowledge system, the cosmological map that the mechanism was computing, was borrowed from civilizations that had been tracking the sky for thousands of years before Greece existed as a mathematical culture. And this is where everything changes. For over a century, scholars assumed that the outer calendar, ring the ring with Egyptian month names, represented a 365-day solar year, because the Egyptian civil calendar was a 365-day solar calendar. That assumption seemed logical. It seemed obvious. Egyptologists endorsed it. It became foundational to how the mechanism was interpreted, how it was reconstructed, and how it was dated. The 365-day assumption was baked into almost every academic reconstruction of the device. And then, in 2024, a team of physicists from the University of Glasgow tore that assumption apart. Their study, published in the Horological Journal in July 2024, used a method nobody would have predicted. They applied statistical analysis techniques originally developed for LIGO, the Laser Interferometer Gravitational Wave Observatory, the instrument used to detect ripples in space-time caused by colliding black holes. Those techniques are designed to extract precise measurements from extremely noisy, damaged, or incomplete data. And the calendar ring of the Antikythera Mechanism is exactly that noisy, damaged, and incomplete. Beneath the ring, previous X-ray imaging had revealed a series of regularly spaced holes. The question was how many holes the full ring originally contained. Previous estimates had assumed 365. That assumption aligned with the Egyptian solar calendar. It was reassuring. It made the story feel consistent. The Glasgow team ran their Bayesian analysis on the hole positions. Their 68% credible estimate for the number of holes in the full ring came back as 354 to 355, not 365. A ring of 360 holes was statistically disfavored. A ring of 365 holes was described in the paper as not plausible under their model assumptions. The number 354 corresponds to a lunar year of 12 synodic months, the Greek lunar calendar, not the Egyptian solar one. A separate independent Bayesian analysis, conducted simultaneously by different researchers, reached the same conclusion. Both studies, using different methodological routes, converged on the same answer. The calendar ring was not Egyptian. It was Greek. It was lunar. Read that again. The ring that had been labeled with Egyptian month names that scholars had been calling an Egyptian calendar for over 100 years, that Egyptologists had used as evidence of Egyptian astronomical influence, was actually tracking the Greek lunar year. This does not mean Egypt was irrelevant. The Egyptian month names were there. The Egyptian framework was used as a reference grid. But the holes, the functional mechanism that actually drove the calendar, corresponded to a Greek lunar system. What the device was actually doing was more sophisticated than anyone had realized. It was cross-referencing multiple calendar systems simultaneously, holding the Egyptian solar framework alongside the Greek lunar framework in a single mechanical structure. That is not simple computation. That is advanced comparative astronomy. That is the kind of knowledge synthesis that requires deep familiarity with multiple civilizations, astronomical traditions, and the engineering genius to encode them all into gear ratios and hole spacings simultaneously. According to informed sources in the field, this finding represents one of the most significant reinterpretations of the mechanism's function in living memory. What most people are not seeing is that this is not just about a calendar ring. It is about what the calendar ring tells us about the reach of ancient knowledge networks and about how casually we have been misattributing the intellectual origins of this device's design philosophy. But the story does not stop there, because 2025 brought a second revelation, and this one cut even deeper. In April 2025, two physicists at the Universidad Nacional de Mar del Plata in Argentina, Professor Esteban Guillermo Sigeti and Dr. Gustavo Francisco Arenas, published a paper on the Archive preprint server that asked a question historians had been deliberately avoiding. Did this machine actually work? not in theory, not in reconstruction. In its actual physical form, with the gear spacings and tooth profiles that we can measure in the surviving fragments, did it function as intended? They built a computer simulation of the mechanism's gear system. They modeled the triangular V-shaped gear teeth, which are unlike modern gear teeth that have smooth curved profiles designed for continuous, even motion. The triangular teeth cause small accelerations and decelerations with every engagement micropulses of irregular motion that introduce cumulative inaccuracies into the system. Under ideal conditions, with perfectly spaced gears, their simulation showed that the triangular teeth produced manageable deviations. The lunar indicator, for example, showed a maximum deviation of about 2, 5 degrees an acceptable margin for the purposes of timekeeping and astronomical prediction. Under ideal conditions, the machine worked, but here's where it gets worse. Real conditions were not ideal. The gear spacing in the surviving fragments is not perfect. It never was, because these gears were cut by hand 2,000 years ago, without computer-controlled milling machines, without micrometers, without the standardized manufacturing tolerances we take entirely for granted in modern engineering. The researchers measured the actual spacing errors documented by previous studies and fed them into their simulation. The results were alarming. Even the tiniest manufacturing inaccuracy and gear spacing errors so small they would seem trivial to the naked eye caused the mechanism to jam. Not occasionally, not rarely, frequently, catastrophically. According to their simulation, the device could only be cranked approximately 4 months into the future before the gears would slip, disengage, and require a full manual reset. 4 months. A device designed to predict eclipses decades in advance, to model planetary positions across centuries, to track a 4-year Olympic cycle, potentially jamming every 4 months. The researchers were careful to note the obvious objection. The irregular spacing they measured in the surviving fragments may be the result of 2,000 years of corrosion, deformation, and saltwater damage, not the original manufacturing precision. The machine they studied is not the machine that was built. It is the machine as it survived. The original tolerances may have been far tighter. The original engineering may have been extraordinary. In fact, given the sheer effort and knowledge required to conceive, design, and fabricate something of this complexity in the 2nd century BCE, the possibility that the finished product was a non-functional showpiece seems almost absurd. It would be like building a working-scale model of the Large Hadron Collider and then discovering it couldn't actually accelerate particles. The builder would have known. The flaws would have been corrected. And yet the simulation exists. The data exists. And it forces an uncomfortable question that the archaeological community has not yet resolved. Was the Antikythera Mechanism a precision scientific instrument that worked flawlessly in its original form? Or was it something more like a teaching model, an educational demonstration device built to show how the cosmos functioned rather than to calculate its future states with operational reliability? Some researchers have suggested exactly that its role was pedagogical, not predictive, that it was used to teach Greeks about humanity's place in the cosmos, to illustrate the mathematical elegance of celestial mechanics rather than to compute eclipse dates for practical navigation or religious ceremony. Think about what that means for everything we thought we knew about this device. The real story is this. The Antikythera Mechanism exists at the intersection of at least 4 distinct knowledge traditions: Egyptian calendrical astronomy, Babylonian mathematical cycles, Greek geometric theory, and Hellenistic mechanical engineering. None of these traditions alone could have produced it. It required all of them simultaneously. And the man, most likely responsible for synthesizing them, Hipparchus of Rhodes, was himself a product of that cross-cultural intellectual environment. He had access to Babylonian records stretching back centuries. He worked in Rhodes, a maritime hub where traders, scholars, and astronomers from across the Mediterranean world converged. He developed the mathematical tools, trigonometry, spherical geometry, eclipse theory that the mechanism physically encodes. The device is not a Greek achievement in the narrow nationalistic sense that popular history has always framed it. It is a Mediterranean civilizational achievement built on foundations laid by Babylon, refined by Egypt, and mechanized by Greece. This matters enormously in the context of Egyptology's long-standing framing of the ancient knowledge hierarchy. For decades, the dominant narrative in archaeology and the history of science positioned Egypt as a civilization of monumental architecture and religious cosmology, and Greece as the birthplace of rational, mathematical, empirically grounded scientific thought. In this narrative, Egypt inspired aesthetically and spiritually, but did not contribute the mathematical precision that made Greek science great. Babylon, similarly, was acknowledged as an astronomical tradition, but framed as observational rather than theoretical. A civilization that noticed patterns in the sky, but lacked the Greek geometric framework to explain them rigorously. The Antikythera Mechanism was cited for generations as evidence of Greek rational superiority proof that Greek engineering had leaped centuries ahead of any comparable civilization, what the 2024 and 2025 research collectively reveals is that this framing was always incomplete, and in certain specific claims, demonstrably wrong. The calendar ring was not Egyptian. In its functional architecture, the Glasgow study proved that, but the mechanism used Egyptian month names as its reference framework, indicating deep and sophisticated engagement with Egyptian astronomical tradition. The Saros cycle encoded in the gears was Babylonian, not borrowed casually, but integrated at the deepest structural level of the device's predictive logic. The differential gear arrangement that drove the lunar anomaly model, a mechanism previously believed to have been invented in the 16th century, over 1,500 years after this device was built, was working inside this bronze box 2 millennia before European clockmakers claimed its invention. The knowledge was not Greek in origin. It was synthesized, translated, and mechanized by Greek engineering. There is a profound difference between those two things. And collapsing that difference, treating the engineering achievement as equivalent to the intellectual achievement, skewed our understanding of the ancient world for over a century. According to informed sources familiar with the ongoing research at the National Archaeological Museum and the broader Antikythera Mechanism research project, the inscriptions on the back cover of the device have still not been fully translated. A 2025 lecture series at the Max Planck Institute for the History of Science focused specifically on new readings of those back cover texts, which contain what appears to be a detailed user manual for the device instructions for its operation, possibly including calibration procedures, correction methods, and astronomical event schedules. If those inscriptions are fully decoded, researchers expect them to reveal additional layers of the mechanism's function that current reconstructions do not yet account for. In other words, the most sophisticated ancient artifact ever discovered is still not fully read. There are still pages of it we have not opened, and there is more we know that complicates the picture further. The wreck in which the mechanism was found has been dated by multiple independent lines of evidence to approximately 70 to 60 BCE. The mechanism itself was already old when the ship sank. Researchers in 2022 proposed that the device's initial calibration date, not its construction date, but the date from which its astronomical calculations were set to begin, may have been December 23rd, 178 BCE. Others proposed 204 BCE as a more likely calibration date. This means the gap between when the device was calibrated and when the ship went down could be over a century. Machines of this complexity, built by hand in the ancient world, were not disposable instruments. They were treasures. They were passed from one owner to the next, maintained, repaired, and almost certainly recalibrated as their mechanisms wore and their predictions drifted. The ship that carried it was also carrying looted Greek artwork statues, bronzes, precious objects thought to be destined for Rome to support a triumphal parade being organized for Julius Caesar. The Antikythera Mechanism was traveling in extremely distinguished company. It was not a curiosity. It was a valued object in the possession of someone powerful enough to acquire it. Who that person was, and why they wanted it, and what they intended to do with it. That question has never been answered. And in that unanswered question lies something that no amount of CT scanning or Bayesian statistical analysis can resolve. Because the mechanism was not just a machine, it was a repository of knowledge, a portable model of the cosmos, a bronze and gear representation of how the universe moved, encoded by minds that understood through a synthesis of Egyptian, Babylonian, and Greek traditions that the sky operates according to mathematical laws that can be calculated, predicted, and mechanized. In a world where most people believed the sky was controlled by gods, someone built a box that showed how the gods actually worked. That is not mythology. That is engineering. And somebody wanted it badly enough to put it on a ship in the Mediterranean, alongside Caesar's loot. Consider the full picture now. You have a device calibrated as early as 204 BCE, built on astronomical data stretching back to Babylonian records compiled hundreds of years before that, carrying Egyptian month names that connected it to a civilizational calendar tradition thousands of years old, encoding mathematical cycles first observed by Mesopotamian skywatchers who wrote on clay tablets, all of it packed into 37 bronze gears inside a wooden box the size of a thick book. And then, in 2025, a pair of Argentine physicists ran a simulation and found that the gears, in the condition in which they survive today, would have jammed every 4 months. And in 2024, physicists who normally study gravitational waves used black hole detection statistics to prove that the calendar everyone thought was Egyptian was actually Greek. And somewhere in Athens, in a fragment that has been sitting in a museum since 1901, there are inscriptions on the back cover that nobody has fully read yet. What most people are not seeing is that each one of these revelations does not settle the story. It opens a new layer of it, Every time science looks more closely at this object, it finds something that the previous layer of examination missed. The 1902 discovery of the gear led to the 1950s mechanical analysis. The 1950s analysis led to the 2005 CT scan. The 2005 CT scan led to the 2021 Nature paper. The 2021 Nature paper led to the 2024 Glasgow study. The 2024 Glasgow study overturned a 100-year assumption about the Egyptian calendar. And in 2025, a simulation from Argentina challenged the assumption that the device was ever reliably functional. The investigation is not converging on an answer. It is diverging into deeper and deeper questions. There is a 10-to-1 scale replica of the mechanism standing over 3 meters tall at the University of Sonora in Hermosillo, Mexico, inaugurated in February 2024, built specifically as a teaching tool for physics students. When those students turn its enormous crank and watch the dials advance, they are learning something that would have been immediately recognizable to whoever originally operated the device 2,000 years ago. That the universe runs on mathematics, and that mathematics can be physically embodied in gears, ratios, and holes. That knowledge did not begin in Greece. It was synthesized there at a particular moment in history, by particular minds working at the confluence of multiple ancient knowledge traditions. And then it sank to the bottom of the Aegean Sea, 60 meters down, and lay there for 2 millennia until some sponge divers needed shelter from a storm. The mechanism that should not exist is still giving up its secrets. The 2025 Max Planck lectures on the back cover inscriptions have not yet produced a complete translation. Ongoing underwater excavations at the Antikythera wreck site, which resumed in 2012, have recovered additional ship timbers and artifacts, but no new mechanism fragments have yet surfaced. 2/3 of the original device remains missing. 2/3 of the most important scientific instrument from the ancient world is still somewhere on the sea floor, or dissolved into silt, or resting in pieces inside rock that has not yet been examined. What else was encoded in those missing gears? How many more dials did the original device have? The 2021 Nature study confirmed that the front of the mechanism displayed all 5 planets known to the Greeks: Mercury, Venus, Mars, Jupiter, Saturn, but the precise gear arrangements that drove those planetary displays have not all been recovered. We know the device modeled the entire known solar system in mechanical form. We know it was operational at least a full century before the ship carrying it sank. We do not know how many versions of it were built, how many hands built them, or how many copies existed before the knowledge tradition that produced them was interrupted by the collapse of the Hellenistic world into Roman dominion. Here is the deepest question underneath all of this. If a civilization in the 2nd century BCE could build a device that modeled the movements of the sun, moon, and 5 planets simultaneously, predicted eclipses decades in advance, cross-referenced 4 different calendar systems in a single mechanical structure, and did so with gear ratios accurate enough to track 18-year eclipse cycles, what else did they build that we have not found? What other instruments, calculators, and cosmological models were constructed in Alexandria, in Rhodes, in Babylon, in Memphis, and then lost? The Antikythera mechanism is described by every researcher who studies it as unique. There is nothing else like it in the archaeological record. No comparable device appears again in human history until the mechanical clocks of 14th century Europe, a gap of less than 400 years. But uniqueness in the archaeological record does not mean there was only one. It means there is only one left. The difference between those two statements is the difference between the history of ancient science and the history of ancient science as we currently understand it. The gravitational wave physicists who cracked the calendar ring used techniques developed to detect ripples in space-time from black holes merging billions of light years away. They pointed those techniques at a corroded bronze ring sitting in a glass case in Athens, and found that a century of scholarly consensus was wrong. The Argentine engineers who simulated the gear system found that the world's first computer may have required a manual reset every 4 months. The Max Planck researchers working on the back cover inscriptions have not finished their translation. The wreck excavation team has not found the missing 2/3. The questions are multiplying faster than the answers. And somewhere at the bottom of the Aegean Sea, 60 meters beneath the surface in the silt and rock of a 1st century BCE shipwreck, the rest of the story is waiting to be read. If we ever build tools sensitive enough and ask questions honest enough to find it. This is not a closed case. This is an open wound in human knowledge. And every new imaging technology, every new statistical method borrowed from astrophysics, every new simulation run on a university computer in Argentina tears it open a little wider. The Antikythera mechanism is not an answer. It is the most sophisticated question the ancient world ever asked us. And we are only beginning, even now, to understand what it was actually asking.